Okay, so today we'll continue with our lesson on topics 1 to 3, which is number systems, factorization, and LCM and HCF. So we'll just do a quick review from the last class. So the first thing that we discussed was number systems. So we learned why numbers are grouped, and we learned about the natural numbers, whole numbers, and integers. So the first number group category that we learned was the natural numbers. So these are, again, counting numbers, very simple. So for example, we have 1, 2, 3, 4, and so on. So very simple counting numbers. The second category that we learned was whole numbers. So again, whole numbers are the same as our natural numbers, the counting numbers, remember, except we include 0. So remember, the natural numbers do not have 0, but the whole numbers have 0. So that's very important to remember. So again, remember, these are the properties of whole numbers that we learned. And remember, I asked a question to you all on if someone could give me an example of one of these properties. So remember, the closure property is when we add or multiply two whole numbers, the result will also be a whole number. For example, 3 plus 5, both of these are whole numbers, and the result will be 8. And 8 is also a whole number. So that is the closure property. Commutative property is when changing the order of 2 or 3 numbers will not change the sum or product. So again, sum is addition and product is multiplication. For example, 2 plus 3 equals 5, right? But 3 plus 2 also equals 5. So no matter the order of 2 and 3, the result will be the same, which is 5. Third was associative property, where grouping numbers does not change the sum or the product. So, for example, 5 plus 3 plus 7 equals 15. But if we group 5 and 3 together, and then we add the 7, the answer will be the same. So 5 plus 3 is 8, right? And then we add the 7, we still will get 15. So these results are the same. And lastly is identity property, where Adding 0 or multiplying by 1 will not change the number. So is there any questions or we can move on?
Rishi sir?
Does anyone have any questions so far or we can move on?
Just you can hold a minute. I will ask a few questions then. What they are just simplicity. Okay, just you can hold a minute. Now what the Rishi sir explaining here? Anybody understanding? Yes. What is this? Properties of whole number. Now, what is the first property, sir? Explain. Closure property. Then. So, are you able to understand? Yes. What is going on the board? Yes. Yes. Say, this is sir. We are understanding. Please be continuing.
Okay, thank you. Good job. Everyone is understanding. So from here we learned the third category, which is integers. So remember we have the natural numbers, whole numbers, and now we have integers. So integers, if you remember, include the positive numbers, negative numbers, and 0. So natural numbers here would be only these. So our counting numbers, 1, 2, 3. Whole numbers would include the 0, correct? So we have the natural numbers of 1, 2, 3, but we also have 0. And then now the third category, integers, includes not only 0, 1, 2, 3, but also the negative versions. So -1, -2, -3. So this whole set of numbers include integers. So this is the last topic that we covered in the last class, and it'll be important to understand, very important to understand for today's lecture. So this topic was understanding prime and composite numbers. And in order to understand prime and composite numbers, we have to understand factors. So remember, a factor is a number that divides another number exactly. So for example, if we have the number 10, we can divide 10 by 5 to get 2. And since 5 divides 10 exactly, 5 is a factor of 10. So this is how we will explain factors. So if a factor divides a number exactly, that number is a factor of that number. So 5 is a factor of 10. So then we have the two types of numbers, prime and composite numbers. So prime numbers have only two factors, and it's 1 and itself. For example, take the number 7. 7 is in fact divisible by 1, so is any number. So 7 divided by 1 is 7. So 1 is a factor of 7. Itself, if we try 7 divided by itself, 7, we get 1. And that's also a perfect division. So we have confirmed that the two factors of 7 are 1 and itself. However, the number 7 is not divisible by other numbers. So 7 divided by 2 is 3.5, but that is not exact division. And so on. 7 is not divisible by 3, 4, 5, 6, for example. So because it is divisible only by 1 and itself, 7 is prime. So the second is composite numbers, and these have more than two factors. So we can take the example of number 10. 10 is divisible by 1, of course. Every number is divisible by 1. Number 10 is divisible by itself. 10 divided by 10 is 1. But it's also divisible by 5, for example. So we have more than two factors. Therefore, 10 is composite. So prime and composite numbers are the two types we have to understand. So is everyone understanding? Is there any questions? This is very important to understand so we can go forward with today's lesson. So if there's any doubts, please ask now.
If you have any doubts, you can ask now.
Explain the composite numbers.
Explain composite numbers again. So remember, prime numbers have only two factors, 1 and itself, right? But composite numbers have more than two factors. So it'll have 1, it'll have itself, but it'll also have other numbers. So number 10 has a factor of 1. See, 10 divided by 1 is 10. That's exact division. It has itself 10 divided by 10 equals 1, but it also has a factor of 5, right? 10 divided by 5, it has a factor of 2. See, 10 divided by 2. So here we can see there's 4 factors, which is more than 2. So therefore, 10 is a composite number. So does that answer your question? Everyone is understanding now? Okay, good. So now we have to learn how do we find the factors of a number? Because once we find the factors of a number, we can determine if it is prime or composite. So we need to be able to find the factors in order to determine this. So the way that we find factors is we list numbers starting from 1. So we'll start 1, 2, 3, 4, and so forth and we'll see if each number divides 48 exactly. So let's start with 1. So we'll start with 1. 1 is divisible, 48 is divisible by 1, correct? Every number is divisible by 1. The next number we'll try is 2. So can someone tell me if 48 is divisible by 2? Yes, it is. 48 is divisible by 2. So we will keep it as a factor. Next, we'll try 3. So is 48 divisible by 3? Correct, it is. So we will keep it as a factor. Then we'll try 4. Is 4 a factor? Correct. But now we have 5. Is 48 divisible by 5? No, it's not. Correct. So 5 is not a factor. So we'll get rid of 5. Then we will move on to 6. So is 6 a factor? Correct. Then we'll try 7. 7 is a factor or no? Correct. It is not a factor. So now we'll move on to 8. Now, what you'll notice is not only is 8 a factor, it's also multiplied by 6 will give you 48. So that's the number that we want. So what this means is that 8 is the highest number we'll test. We won't test numbers higher than this. For example, we won't go to 9. We will not try 10 or 11, for example. So 8 is the highest that we will go. So we'll just add a line in the middle and we'll match the numbers that multiply to 48. So now for here on this side, we went down, right? We went 1, 2, 3, 4. Here we'll go back up to see which numbers multiply with these numbers to equal 48. So we start with 8. 6 times 8 is 48. Now, what do we multiply by 4 to get 48? 12, correct? So 12 times 4 is 48. Now, what about 3? Correct, 16. 16 times 3 is 48. Next, we'll try 2. 24, correct. And then lastly, 1. 48. So now we've finished our list of factors. Where is it gone? Okay, sorry. So we have 1, 2, 3, 4, 6. We have 8, 12, 16, 24, and 48. So this is our factors list. So these are all the 10 factors, right? We have 10 numbers here that are factors of 48. Sorry. Okay, so now has everyone understood? We can move on to the next example. So the next example we have, we'll find the factors for this number as well. This number is 56. So all of you guys are understanding well, so we should be able to do this example pretty quick. So again, what number do we start with? 1, correct? Next, we try 2, right? 2 is a factor? Yes. Now we have 3. Is 3 a factor? Correct. It is not. So now we will try 4. Yes. Next, we have 5. No. We'll try 6. Oh, is 6 is a factor of 56 or not? See, so final answer, 56. 6 is a factor or no? No, it is not. Because 56 divided by 6 is not a whole number. Remember, for it to be a factor, it must divide into a whole number. And 6 does not meet that criteria. So 6 is not a factor. So now we'll try 7. Yes. Then we'll try 8. Yes. But now we see 7 and 8 multiplied equals 56. So now that's our upper limit, and we'll start going back. So again, we'll draw the line. We'll start with 8, right? 7 times 8 is 56. Now we'll move on to 4. So what is our second factor here? Someone know? 14, correct. 4 times 14 is 56. Now we have 2. 28, correct. And lastly, 1 is, of course, 56. So this is our factors list for 56. So these are our 8 factors. So is there any doubts, or we can continue? Good job. Okay, so see, this is my mistake. We'll just ignore this. Remember, this was for 48. So we'll try for 17. So again, we'll start with the number 1. It is a factor, of course. Is 2 a factor? No. Is 3 a factor? Is 4 a factor? 5, is that a factor? So you'll see as you try 6, 7, 8, and so on, none of them are factors. Only until you reach 17 will you find another factor. So what does this mean? What type of number is 17?
Prime number.
Correct. So 17 is prime because it has only two factors.
1 and itself.
Correct. One and itself. Okay. Good job. So I think you guys are all comfortable with finding factors, and we can determine from the factors if a number is prime or composite. So the second type of number we want to learn, so we've covered factors, right? Now we want to learn something called multiples. So you can think of factors as division and multiples as multiplication. Sorry. So factors are for division and multiples are for multiplication. So a multiple is what you get when you multiply a number by a natural number. Sorry, so I don't know why that keeps happening. So factors, again, are division and multiples, multiplication. Sorry. So a multiple is what you get when you multiply a number by these numbers. Can someone remind me what are these kinds of numbers? Remember the categories, correct? Natural numbers. Remember, natural numbers are counting numbers, so 1, 2, 3, 4, and it does not include 0, so no 0. So, for example, the multiples of the number 6 are as follows. So we'll start with 1, then we'll go to 2, 3, 4, for example. So 6 times 1 is 6, 6 times 2, and 18, correct. So if we continue, 6 times 4 is,
28.
and continue like this. So all of these numbers here, 6, 12, 18, 24, they're all multiples of 6. And the reason we include only the natural numbers is because 0 is a multiple of every number, right? Anything times 0 is 0. 24 times 0 is 0. 1000 times 0 is 0, and so on. So that's why we only test the natural numbers, because we already know that 0 will be a multiple. So is there any questions so far? No, everyone is understanding?
No.
Good. So again, here is a little bit more on factors versus multiples. So remember, factors are division and multiples are multiplication. So one thing to understand is the factors of a number usually are limited. For example, the number 24 has only 8 factors. right? 1, 2, 3, 4, 6, 8, 12, 24. So it will never have more than 8 factors. So it's limited at 8. However, multiples are infinite, right? Because we have 6 times 1, we have 6 times 2, times 3, times 4, times 5, times 1,000, times 7,500, for example. So the multiples of a number will never end. It'll go to infinity, right? It'll never end. So factors are limited and multiples are infinite, so not limited, right? So let's do this example together. So we'll first write the factors of 24, then we'll write the first 6 multiples of 4, and we will find which numbers are common. So let's start with the factors. So we start with 1, then we test 2, then we test 3, then we test 4, then we test 5. Is that a factor?
5 is a factor for 24?
Correct, it is not. So now we'll go on to 6. But 6 times 24 6 times 4 is 24. So we'll draw the line and we'll start with 6 and go up. So we have 3, 8, 2 is 12, and then 1 is, of course, 24. So those are our factors of 24. So now let's write the first 6 multiples of the number 4. So what number do we start with? 1, right? We want to start from 1, 2, 3, 4, and so forth. So our first multiple will be 4. Next, we'll try what number? 2. So these are the first 6 multiples of the number 4. And now we will circle which ones are common. So we'll start with 4. Is 4 a factor in the factors list? So 4, is 4 in the factors list? It is, right? So we'll circle 4. Is 8 in the factors list? It is. Is 12 in the factors list? Is 16 in the factors list? No. Is 20? And 24. Good job. So we have 4 in common between the factors and the multiples. So 4 in common. Okay. So here is where we'll start to combine factors and prime numbers. So this is what we call prime factorization. It's when we write a number as a product of prime numbers only. For example, and what I mean by a product of, for example, we can write the number 24 as the product of 4 and 6. So that's what I mean. However, in prime factorization, we'll use prime numbers only. So how do we do this? Prime factorization breaks a composite number into prime factors. And again, the answer uses only prime factors, prime numbers. And the way that we solve these kinds of problems, the way that we perform prime factorization is through the tree method. The tree method to find the prime factorization of a number. So now let's see how we actually do the tree method. So here is a tree method, and it's a visual way to break composite numbers down. So we start at the top with the number we want to factorize, and we'll split it into any pair of factors, so any factors that we want. And we'll continue to split each of these numbers into factors. And once we reach a prime number, remember prime numbers are, for example, 2, 3, 5, 7, and so forth, that's when we will stop. And this number that we get when we stop is one of the prime factors. So is there any confusion? We'll see an example in a second with prime factorization and factor trees, but is there any confusion in this concept? No? Okay. So here's an example. Let's find the prime factorization of 60. So again, we start with 60 at the top, and we'll split it into two factors that multiply to 60. So can someone give me two factors? You can raise your hand.
Raise your hand. Say loudly.
12, correct. And what number is the second one? 5, correct. So from here, we'll continue to split. So we'll split 12 into two factors, and we'll split 5 into two factors. So we'll begin with 12. So can someone give me two factors that multiply to 12? 6. And the second? 2, correct. So 6 and 2. Now what about 5? Can we split it into two factors?
No.
So what kind of number is 5? Prime number, correct. So what does this mean? 5 is one of our prime factors. So this branch ends here. We'll not continue because we cannot split 5 into two factors. So now we'll start with 6. So what are two numbers, two factors we can split 6 into? And 2, correct. And now what about 2? Can we split it into two numbers? No, we cannot, correct? So 2 is prime, correct. So we'll continue with these two numbers. These are the branches we have left. So 3, can we split it into two numbers? No, we can't. So 3 is also prime. And lastly, 2 is prime. So we have successfully completed our factor tree. So each of the numbers we have circled, so 3, 2, 2, and 5, are our prime factors. So we can write the number 60 in terms of the prime factors. So the prime factorization of 60 is 3 times 2 5. So 3 into 2 into 2 into 5. And before we finalize our answer, let's just test this to make sure it is true. So 3 times 2 is what? 6. 6 times 2 is, and 12 times 5. So 60 is our answer. So our answer is correct. So the prime factorization of 60 is 3 into 2 into 2 into 5. So is everyone understanding how we do factor trees? Or is there any confusion still? Okay. So the next concept is LCM and HCF. So LCM is what we call the least common multiple. So it's the smallest common multiple, so multiples that appear in both numbers for two or more numbers. So we begin by listing the multiples of each number we're comparing, and we'll find multiples that are common, so multiples that appear in both lists. From here, we'll choose the smallest multiple that appears in both lists, and that number is our least common. So one thing that is useful when we're finding least common multiples is for finding common denominators. So remember, in a fraction, this is our denominator. So LCM is good for finding common denominators. So let's see how we can find the LCM. So we want to find the LCM of 21 and 6. So we'll start by listing out different multiples of each of the numbers. So we'll start with 21. So what number do we test first? Always. Can anyone tell me?
One.
1, correct. So 21 times 1 is 21. Next, we'll try 2. So 21 times 2 is
42.
42, correct. And let's do 4. So let's try 4 multiples. So we'll do 21 times 3 is what? 63. And 21 times 4 is what?
64.
Good job. Okay, so here are the first 4 multiples. So now we will do the same for the number 6. So we'll start with 6 times 1, which is, of course, 6. Then we have 6 times 2,
12.
12. 6 times 3,
24.
so here we have our first 4, but we don't see any in common. So let's continue multiplying or finding the multiples for 6. So we'll do 6 times 5,
30. 36. 40.
next one. Okay, so here we can see we found 2 numbers that are in both of the lists, so both in 21 and 6. So 21 cannot be an LCM because 21 is not in this list. However, we can see 42 is in both of the lists. So we can see that 42 is the first number that appears in both lists. So that is our LCM, least common. Correct. So 42 is the least common multiple between 21 and 6. So is there any doubts or we're good with this concept?
No.
Good. So are we doing good on time? Is how much time is left or how much time is left available?
Time over, sir. This is the time already over.
So we have more time for it today or no?
No, no.
Okay. So good job today, guys. We'll finish these topics in the next class, and I'll upload the recording of the class to YouTube, and you'll be shared the video so you can recap and relearn if you have forgotten or need to understand anything, or if you have any doubts. So good job today, and thank you for having me. So hope you all learned something today.
Thank you. Rishi sir, can you appear on the full screen once?
Sorry?
Can you appear on the full screen? Full screen. Just once.
Sure. Let me unshare this one.
Yes. 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 Just. Yes. Thank you, sir. Thank you. Thank you very much.
Thank you. Yeah. See you guys in the next one.
Thank you, sir. Bye. We'll see you by next class. Yes, you may go. You may go to the class. This